So welcome everyone to our July Immerse Yourself. I want to thank everyone for coming here in person, as well as everyone joining us here on Zoom. And I also want to thank this month's sponsors, which is Patty and David Gross. So thank you very much to them for sponsoring our speaker this month. For upcoming events, this week on Saturday, we have Patty Women's Dive Day, and we also have guided tours complimentary with your admission. If you're already a member of the museum, those tours are included with your membership. So just come on in at 11 o'clock or 2 o'clock on Saturday, July 19th for our Patty Women's Dive Day guided tours. Learn all about the women pioneers of diving history, as well as our amazing exhibits and all the history they have. Next month's speaker is going to be on Wednesday, August 20th. That is going to be Mike Ward of Dive Lab. He will be taking us through the history of Dive Lab, its mission, the testing and research development it takes part in, as well as their contributions to military, scientific, commercial, and recreational diving. This month, we have Don Liberatore, who is joining us. He is a submersible pilot and engineer with over 1,700 dives in 5 different vehicles over a 34-year career. So I personally can't wait to hear all about it. And without further ado, I'm going to let Don take it away.
Great. Thank you, Julia, for the introduction. I want to make a few thank yous as well to Dr. Sally Bauer and her husband for setting up this amazing museum here in the Florida Keys. Lisa and her staff for inviting me here to do this lecture and for the technical help on getting it all together. Special thanks also, as she mentioned, to Patty and David Gross, our sponsors and our good friends. They're watching from home, I hope, and enjoy the presentation. Also, thanks to a couple of people from Harbor Branch Oceanographic, Brian Cousin, Jim Masterson, my old boss, Roger Cook, and a gentleman named Lenny Whitlock for their help in providing me with some of the slides and videos and background information on what we're going to talk about tonight. I also want to thank my wife, Dr. Shirley Pomponi, who's sitting right here, for helping me get this PowerPoint presentation almost looking like I know what I'm doing. Almost, not quite. And thank you guys also for being here in person and to everybody that's out there at home watching online. All right, so tonight's talk, it's going to be about submersibles and lockout diving, the history of the Johnson Sealing program, which I was heavily involved in, and some of the engineering and the tools associated with that we built for the marine scientists. And then we'll go over a few of the missions that I thought would be of interest to the group here, and we'll talk a little bit about that. So what is a submersible? There's a big, long explanation from the American Bureau of Shipping and the oceanographer of the Navy, but it's up here on the screen, and we've shortened it a bit. But basically, a submersible, as it differs from a submarine, a submersible is a small vehicle, of course, and autonomous. It is by itself, although it needs a support ship, a mothership to take care of it, transport it to and from the dive site, and to tend it during those dives. The Johnson Sea Lynx, and short duration dives usually as well. The Johnson Sea Lynx were research submersibles, and as opposed to a tourist sub or one that some of the wealthier people have for personal use. A submarine, true submarine, of course, is an autonomous vessel, and it stays out much longer, long duration dives. Now, what is a lockout submersible, which the Johnson Sea Lynx were? A lockout submersible, according to ABS, is what's up here. But in general, when I told people that I was a lockout diver in the early days, they look at me with a blank stare and say, kind of what was that? So most people do know what a diving bell is, if you mentioned it. And that's a chamber that you lower on a cable, right? And the diver can get in and out to the work site. That term lockout comes from an airlock or a gas lock. Okay, and that's defined as a compartment with a controlled pressure space with one or more doors or hatches on it that allow movement between areas of differing pressures. As I mentioned, the Sea Lynx were lockout submersibles, and the submersible had a portion of the hull that was capable of being pressurized with a hatch that would open and the diver would get out, do the work on the bottom. This system was in active use between 1971 and 1987. Now, we discontinued that use because over the 80s, we increased the depth rating of the submersible from 1,000 feet as originally built to 3,000 feet. The investigators we were working with at the time said, well, the lockout system is limited to the depth rating at the time was 350 feet. We want to go look deeper. So we eventually discontinued the use of that lockout system. A little bit on the development of the Sea Link program. Johnson Sea Link 1 was commissioned in 1971. They had an accident right here in the Florida Keys, and I'll talk a little bit about that later, in 1973. In 1975, Johnson Sea Link 2 was commissioned, and we also bought and refurbished the submersible in 1992 and commissioned it, and that was the submersible Clelia. Collectively, more than 9,000 dives between those three vehicles over the years. Now, the man behind all that was Edwin A. Link, and Link joined forces with J. Seward Johnson, a philanthropist who was also the founder of the Harbor Branch Oceanographic Foundation at the time, and together they developed the Sea Link program. Ed Link began his career in the aviation industry and opened a flight school. He learned how to fly in the 20s. And in 1929, he developed the Link Trainer, which was a flight simulator. It was later sold off to the Army Air Corps, and they trained people, pilots in this device all the way through World War II. In the 1950s, Mr. Link became interested in archaeology and treasure hunting, some of it done here in the Florida Keys. In the 1960s, that led him to his Man in the Sea program, and he started developing equipment, tools, and technology, diving gases as well, experimenting with helium and oxygen back in the 60s. This is one of his underwater habitats. It was a rubber dwelling. Okay, now here's that SDC that I mentioned. You can see in the upper left there, laying down as a decompression chamber, and over here as a diving bell, and that's the actual unit going in the water over the ship's side. In '64, he built the submersible, portable, inflatable dwelling. Real sketchy picture there, but that's it. It's an inflatable habitat, and he conducted a series of dives with two divers, in this case, using the SDC as the diving bell, and they'd get in the habitat. That was a 430-foot dive, and it lasted 48 hours. So saturation dive, and the gas used in that one was 96% helium and the 4% oxygen. I believe that one was done off of Villefranche in France. And after that series of dives, Mr. Link decided it was time to make basically a mobile diving bell. That's when he started in with the manned submersible and a lockout submersible at that. This is Deep Diver, built in Riviera Beach, Ed Link's design, and John Perry, who ran Perry Submarine Builders in Riviera Beach. This sub was launched in 1967, and in 1967 they did a record-breaking dive, 700-foot lockout using 93% helium and 7% oxygen. Shortly thereafter, same year, it was discovered that there were some problems with the weld up where the conning tower is located, and the sub was taken out of commission, decommissioned. All right, that led Mr. Link, and let me point out here on Deep Diver, let's see if I can get the mouse to work here. A few areas. There's the pilot's compartment there. You see this hatch right over here that separated the two. Diving compartment in the back. This external hatch, or what arbitrarily was called A hatch, on the outside, and hard to see, but right up in here was another hatch called B hatch. That's the internal hatch, and we'll talk a little bit about that later. Now, after Deep Diver was decommissioned, Mr. Link decided to move on, got with Seward Johnson Sr., and developed the Johnson Sea Link submersibles. And you can kind of see A similar design, a pilot's compartment up front, a diving chamber over here, and a main battery down here, just like on Deep Diver. Deep Diver had steerable thrusters. This is a later version of the Sea Link with fixed thrusters, but 9 of them around the vehicle. Now, that diving chamber I mentioned, this is actually the diving chamber out of the Sea Link as we were doing a test on it. And I just brought that up for reference. It's 8 feet long and about 3.5 feet in diameter. So a pretty small little chamber. This slide shows the Sea Link mated up to a deck decompression chamber, which was done after the dive. When the diver got back into the submersible, he would close that internal hatch or B hatch, open a valve up, and pressurize the compartment a little bit over bottom pressure. So that hatch would seal up. Now they were able to come up off the bottom, still maintaining whatever depth they were at, get up onto the surface, and the crane would lower the sub, which is right here, the pilot sphere, the diver compartment. And this right back here is a gas storage sphere, so it's not a place where people go in. Anyway, it made up to what's called the transfer trunk, which is right in this area. This dark black line here is actually the deck of the ship. And our chamber, a 60-inch wide double lock chamber, was down below the deck of the ship. So we'd made up to that through the transfer trunk, climb down, adjust the pressures, and then the divers could be in the big, comfortable chamber and finish out their decompression there. Just a little shot of the A hatch on the Sea Link. That's the external hatch, as I mentioned, and a shot looking up on the bottom of the sub at that A hatch in the closed position. But you see those big holes there. That's where that's a mating flange that sat down on that transfer trunk that I mentioned, and 24 big bolts would be put in by the deck crew to mate that up to the DDC. This internal shot, you can see how small that compartment is. But what I wanted to point out was B hatch, and there it is, kind of folded up, not being used at the time, but it would go down, and they could overpressurize. I threw this picture in just because we're in the most amazing collection of helmets that I've ever seen, and probably close to in the world. But this is an unusual helmet that was used, the Sea Link in the background, called the Helmax, which we found out tonight is not in the collection. Doesn't mean she doesn't have one. That's right. But it's not here as far as we know. Anyway, it's a big helmet, and he's wearing a rebreather, a CCR 1000 on the back. Now, those are big, heavy pieces of equipment, and they're good, but they take up a lot of space. And in the small confines of the Sea Link, they were not used any longer. We finally went to Kirby Morgan Bandmass, which there's one right here, Kirby 9. We had 9s and 10s, and an open circuit system. The Sea Links carried a buku gas on board, just so much gas that it wasn't worth using the rebreathers and taking up that space. All right, I mentioned the accident earlier. That happened here in the Keys, I said, down at the Key West. It was in 1973, and they were diving on a wreck, an artificial reef called the USS Fred T. Berry. The day before, science had gone down and with the sub and installed a fish trap. They were checking the fish population around the wreckage. The next day, the dive happened, and it was planned to be a very short dive, only an hour long. They'd go down, grab that fish trap, come back up to the surface, and they didn't carry any diving gear. They didn't carry any thermal protection with them. And unfortunately, as they were proceeding around the wreck at about 360 feet, they snagged the cable that was hanging off the wreck. The sub was unable to surface. They settled back down to the bottom and waited. A bunch of rescue attempts were made. The Navy came in, tried to put hard hat divers on it. The current blew them off. After 31 hours, finally, a remotely operated vehicle, or ROV, was able to come in with a grappling hook on the front. It hooked into the tail of the submersible. They pulled on it, and cable broke, and they came up to the surface. Unfortunately, 2 people lost their lives. The 2 people in the back compartment, that was Clayton Link, that was Ed Link's son. Ed was on board the ship, and Al Stover, and both of them succumbed to respiratory acidosis and hypothermia. Reasons for the accident: a little bit of poor mission planning and preparation prior to the dive. But the main problem was the failure of the chemical that they used to scrub the carbon dioxide out. It failed at the cold temperatures. The diving chamber is aluminum, transfers heat very well, so it got really cold, ambient temperature in the back. After the accident now, a lot of things changed. The whole operation became more robust, and operational procedures and protocols were developed and adhered to strictly. Mechanical changes were made to the submersible, training programs put in place, and we developed some rescue capabilities. We developed a vehicle called CORD, or the Cabled Observation and Rescue Device, and we also built Sub 2, Johnson Sea Link 2. One of the big things was we carried a good supply of chemical that was good at the cold temperature as an emergency backup, and that was a chemical called lithium hydroxide. This is just a shot of that cabled vehicle used for rescue, and it's a low profile, very streamlined vehicle, little arm on the front, cameras. But the main feature of this vehicle was that the control cable that ran it was very thin, 3/8 of an inch in diameter. And some of the ROVs these days have got a big, cable this big around, an inch and a half or so, maybe more. And that was enabled this vehicle to operate in the Gulf Stream with a very swift currents, because there was a low drag coefficient to that. Later on, CORD was retired, and we replaced it with another ROV, a very powerful ROV. It's got a mechanical arm on the front there. You see it, that's very powerful. But it also was equipped with a cable cutter that could extend out and rotate to various positions. And if that cable problem happened again with the submersible, this vehicle was able to cut it. Wire, rope, whatever, didn't matter. All right, now we'll talk a little bit about the development of the Sea Lynx. And we'll start this video, hopefully. And there it is. This is the sub in its original configuration in the early 70s. Mr. Johnson on the left, Mr. Link in the middle, and a gentleman named Eugene Walden. That was the director of Smithsonian in Fort Pierce at the time. And here you can see very bare bones, ballast tank up over here, chamber in the back, steerable thrusters in the back, which we got rid of, and another early version of the sub, pilot sphere in this case, and a rudimentary manipulator on. Things were improved. We developed new thrusters, which are on the sub, gas storage cylinders, a rescue buoy up in front, a new arm, and some other tools. This shot shows one of our older research vessels and the sub on the back deck. And you can see that A hatch right over there in that shot. Right there is that transfer trunk that we talked about. The sub's not on it right now in that picture, but the next shot you'll see it actually sitting. This is during a transfer. You can see the bolts in there, and that's the interface where the sub and that chamber below deck met. Just a reminder where that was, okay? There's the deck of the ship, and there's that transfer trunk with the man climbing down. All the hatches were operational by people on the outside. This is looking into that 60-inch chamber through the entrance lock. You can see the cots in the back of the main lock. Control area for it, run by one person. All the gas controls came to that panel up in there, and you can control all of the pressures. This is a diver getting out of the sub. There was another guy inside the tender who was fully dressed, ready to go, except for the helmet. And he would tend the diver's umbilical, but his umbilical was always a little bit longer than the diver's in case of trouble. Okay, not only did we develop tools and such, we also did all the work ourselves there for the most part. We had engineers, welders, technicians. There you saw a new sphere coming in, and we did all the piping, bending all that tubing, electrical work, put new battery cells in. This happened about every 5 years at Harbor Branch at our facility. Those battery cells there, you see them going in the box. Each one weighs about 200 pounds, and there are 14 of them. All new pressure cans, cablings, relays, all underneath the sub and located all around the vessel. There we are putting new cables and getting that battery installed back on the sub. That battery, incidentally, was jettisonable. That was another safety feature. You can get rid of it and gain about 3,500 pounds of positive buoyancy in that case. Then we'd roll it out, take it for a couple of test dives, and go out on some other missions. Basic specifications on the Sea Link: we were a Class A1 band submersible by American Bureau of Shipping, excuse me. Construction: mostly welded aluminum, the framework, the ballast tanks, the diving chamber, all aluminum, and the acrylic sphere. The sphere now, the new ones that go to 3,000 were rated, were 5¼ inches thick, just for reference. Original design depth, I mentioned 1,000 feet. We upgraded in 1988 to 3,000 feet of seawater. 4 occupants in the sub, always 2 crew members, 2 crew members and 2 scientists or 2 observers or engineers, whatever, what have you. The basic dimensions: it was 27 feet long, 9 feet wide, and 11 feet high, and weighed in at 28,000 pounds or 14 tons. In air, that is. In the water, we could change our buoyancy. Main battery was 28-volt DC, and weighed in at about 3,350 pounds in air. Emergency life support on board the sub was good for 5 days. We had enough O2. We actually had enough O2 for 10 days, but enough chemical on board to support that carbon dioxide scrubbing for 5 days for 4 people. And an average dive day really was 2 dives a day, 3 to 4 hours apiece on the length of the mission. A few more pieces of equipment to point out. Once again, there's the acrylic sphere. We had 9 1¼ horsepower thrusters. That's these yellow nozzles here. Emergency battery, this little box on the back to run life support equipment and communications with the surface should the main battery go out. The dive chamber we talked about, and the main battery was located down at the bottom there. Up on top, we had a 1,000-watt Harbor Branch developed xenon arc lamp, which was a tremendous headlight for us. We had active and passive sonar on board, which meant we could look out for items on the bottom with the active, but we could also listen for pingers or beacons on the bottom, much like as inside the black boxes in aircraft nowadays. Camera boom over here is hydraulically operated, and our manipulator arm, 7-function arm on the side over there. A few more things just to point them out. Diver ballast tube, this tube that runs along there, part of the framework, we called it diver ballast because during a dive, we would flood those tubes with seawater, make the sub heavy, and that compensated for whatever weight the diver was in his equipment as he got out, so the sub would not float up off the bottom. Also, emergency beacons and underwater telephone communication equipment with the support ship, and gas storage everywhere. We had bottles in the back, bottles underneath, and this big gas storage bottle in the back. Up front, hard to see, but that was our collection carousel, but we'll see that later. Some of the internal stuff, there was a lot of electronics, but the important stuff was life support. We had an oxygen bleed system, and that put O2 back into the atmosphere for what your body is burning up metabolically. And we also had canisters, that's this right here, full of chemical to scrub the carbon dioxide out. And of course, we had monitors for both of those gases and kept track of that during the dive. A lot of tools were developed for the submersible for science, but here's just a few of them here. You see that camera boom now in operation, and the camera was on a pan and tilt with lights and lasers and can work in conjunction with the mechanical arm, the manipulator arm. So, and that is a benthic sampling tool. We had a jaw on there, a scoop, a suction device, and a rope cutter built in for just general purpose for doing things. And here it is in operation. That's just the bare arm. You can see the jaws left and right, up and down, and open, close, of course, and it would rotate 360 degrees continuously, so we could actually turn a shackle or turn a pin if there was no other equipment installed. Pretty beefy arm. It could lift a lot of weight, but it was also pretty delicately pick up fragile things like the sea fan, and we put it in a basket or a box built for that purpose. And those tools were interchangeable. We take those boxes off, put a different set of equipment out front, which you'll see a little bit later. Here's the suction device being used, and sucking samples up off the bottom, but where'd they go? And the important thing about all this, that we could selectively grab samples without disturbing everything around it, you know. And that scoop had a pretty good hydraulic cylinder on it, so when those two stainless jaws came together, it could bite things off that were fairly hard. There's the carousel collection device that's built in. We rotated the buckets around. We could carry 12 10-inch buckets that you see there, or 24 smaller 6-inch buckets with different lids and devices that would go inside. These are just open. We also built a bunch of tools to operate in the midwater. What I mean by that is anywhere off the bottom in the water column when you're not sitting on the bottom. These devices were plexiglass with a door that opened and closed, and we would drive up under the animal and then close the doors off. And because they're plexi, they were good insulators, and they kept the animals cold until they came to the surface. Here's a swimming sea cucumber going down into the bucket, and we close it off. There was 8 of those out front. Now, we also did work with scientists that were interested in bioluminescence, and they would provide us with a low light level camera. You see it being turned on here. We built the screen out there, and we would drive ahead at night in the dark in the midwater column and watch the bioluminescence hit the screen. The idea was to try and determine what those animals were by their trail like that as they hit. Now you see here, there's that swimming sea cucumber up against the screen. It was very evident what that animal was, and that's what they were trying to do, determine what's in the water column. All right, not only did we develop those kind of tools, when I say we, it's the royal we with everybody at Harbor Bridge, tools for equipment development for launch and recovery. The device you're looking at there, we call the drop lock. It was a device to lift the submersible, hanging from the ship's crane right there on the big rope, which was about 5.5 inches in diameter. Up on top of the sub was a receptacle for that device. And as you can see in this photo, it's going down into the receptacle. The leaves are open on it. And the next one, you see, as it passed the ring, the leaves collapse. It goes down inside. The leaves open up again. They pull tension on the rope, and those leaves have the sub. There is no way that that's going to disconnect. But it's also quick acting, which we'll see in a little bit here on the disconnect. All right, we're going to take you on a little ride along on a typical dive. Actually, Shirley and myself in the sub. Typical dive day. About an hour before the dive, we would do a full checklist, make sure everything's working. We're getting down into the submersible. After a meeting, we'd have a general meeting, talk about what's going on, and then we'd go load up the sub. And the ship's crane, this is one of our newer vessels, the bigger ones, that had an A-frame on the stern. And they would lower us down into the water when we were on site. And you'll see in a minute here the drop lock, but there's the back of the ship. You can see the ship's propeller. We're pretty close at this point. There goes the pilot's activating a valve now, and the drop lock disconnects. The idea is get away from that ship as quick as possible. The pilot just released, that would be me. The pilot just released the tow rope, and we've gotten permission to dive. Now we're going to go down. We open a few valves on the outside and flood the tanks. Sub goes down at about 100 feet a minute. So to get to 3,000 feet, about half an hour, get down to the seafloor and do the work. In this case, it's collections. You can see the arms and that scoop that I mentioned we saw before in use, working on an overhang, which was very handy. All of that run from some control boxes that were operated by the pilot. That's the hydraulic box, but right next to it is the thruster control box. So you had to drive the sub, operate that, watch life support, and do a lot of things all at once. There is stuff going down into the compartment, the carousel, and the suction device, collecting a few things. And then we go on to search for the next target. In this case, we happened to cross a grouper on the bottom, just shot a little video. Once the dive was over, we'd head up to the surface and then stop at about 50 feet. That way we'd look up and make sure the ship wasn't directly above us, but they were close. They would come up alongside of us, we'd go to the surface, and once we got to the bow of the ship, we'd turn perpendicular then to the ship, and they were motoring ahead very slowly while we were sitting there waiting. And in just a second, there's the stern of the vessel. One of our crew members, a swimmer, jumps over and carries the tow rope out to the front of the sub. Again, the ship moving slowly ahead. They take us under tow, and here comes that lifting device, the drop lock, quickly installed, and then we are coming up. Once they pull us up into the A-frame, there were two big steel latches that actually grabbed underneath that receptacle and kept the sub locked in as well. They're up in the A-frame, coming over inboard now and set down in the cradle. The crew would get out. Scientists would gather around the sub once they were cleared to come out, and it was safe to come out there. And we'd offload the samples. You can see again that carousel was turning around, full of samples. Sometimes all of them were full, sometimes only a few of them. So that's the end of the dive. Now here's a mission that I wanted to mention because it was a unique project called SCORE, and it stands for Scientific Cooperative Operational Research Expedition. Anyway, it happened off of Freeport, Bahamas, and in about 60 feet of water, there was the Hydrolab habitat. And that was owned by NOAA, still is, I think. There's a picture of Hydrolab. Down near the shelf edge was a diver way station, but what the Sea Link was involved was picking up divers here at the habitat and running them to an area over the edge. There was an anchor installed here and a cable, I don't know if you can see it there, in the artist conception, down to the submersible. Now the sub would, and you can see a diver locked out right there. This is a shot of the Sea Link hanging on that cable. So they were actually locking out in the midwater. The sub was not sitting on the bottom. And we believe that was the first time, probably the only time, that a sub was a lockout sub deployed a diver in the midwater column. Very interesting project. All right, another mission that we were involved in was the Florida Oceaneering Reef, which extends from Fort Pierce, Florida, nearly up to Cape Canaveral. Here's a healthy reef, and this is probably 40 to 45 years ago. This video was taken. You can see lots of groupers, lots of fish swimming around. Looks like it's in good shape. One of our scientists, John Reed, who gave this lecture extensively on the Oceaneering Reef last year here at the museum, he's locked out, and we used that a lot back in the 70s and early 80s on that reef system, the Oceaneering Reef, which is a deep water coral reef. And he was deploying some experiments there, but he got NOAA to approve that area as a habitat area of particular concern, and in that case, protected. This you're seeing the white section there is actually the live coral reef. The depths here are about 240 to 260 feet. And the reef can grow to about 15 feet high, if I remember right. This shot was taken in 2001, north of Fort Pierce, outside the protected area. But the reef has been decimated by shrimp trawlers fishing for rock shrimp. So that was important work that was done early on. We also worked extensively on the Civil War ironclad, the USS Monitor, and Captain Bobby Scully gave an interesting talk on this last year, also on the Monitor. But I'm just going to touch a little bit on our involvement with the Monitor. Just briefly, the Monitor went down in 1862 off of Cape Hatteras. The unique feature was the gun turret, of course, and the low freeboard of the vessel, and the armor belt that went all the way around it. You can see here in the animation, the sinking, it went upside down, turret fell off, and the wreck landed on top of it upside down. This is shot in the early years in the 70s. Also, looking down the armor belt on the port side, because the vessel is upside down, there's the gun turret on the bottom, and that armor belt, which is 5 feet high and 3 to 4 feet thick in places, alternating layers of iron and pine for that armor belt that ran all the way around the monitor. Another shot coming up here, just on the bottom, running along the vessel. And there's the gun turret and the armor belt. Now, we did an expedition in 1977 with lockout divers, and 1979. Lots of artifacts were around the wreck, and a few of them were recovered. This is the 1979 mission, where we actually trained the archaeologists as lockout divers, and we did a grid system on the wreck, and they're using a suction dredge to get down in the excavation pit, and also locked out going inside the wreck to look for objects. This particular one is from 1977. One of our lockout divers lifting a piece of iron deck plate, and that was brought up for investigation. We also recovered the signal lantern that was used the night of the sinking, and that's in the Mariners Museum in Newport News. 1984, we went down and cut the anchor cable, anchor chain rather, and brought the anchor to the surface twice. One time the lift bag broke, came back down, very concerning for us sitting in the sub at the time. And second attempt went well. Here it is coming up, being put on the ship. And that is also in the Mariners Museum in Newport News. We were lucky enough, there it is sitting on the deck of the ship. And in 2002, we did many dives other than that over the years. 2002, we were lucky enough to be invited to go up for a couple of days and be basically a camera platform for the Navy for bringing VIPs, reporters, and such down. And that was just a shot. We saw some of the Navy divers working. This was on the final day, the recovery of the turret. And just to mention, the turret is 9 feet high, 20 feet across, and 8 inches thick with 8 1-inch thick iron plates. Also at the Mariners Museum, I don't believe it's on display as yet. We also worked extensively on the recovery of the Space Shuttle Challenger. And everybody remembers the Space Shuttle exploded in 1986 off of Cape Canaveral at about 9 miles high. It spread debris all the way from the beach, about 45 miles offshore to in 1,400 feet of water. An area of about 450 square miles. Ships were deployed to tow side scan sonar around to look for the wreckage. We were brought in about 2 weeks after the accident to identify those targets that were found with side scan sonar, some of the debris floating on the surface. Our job was to find the targets, identify it, not us personally, but the engineers from NASA and the rocket company, Morton Thiokol. The cable you see there and the big shackle, we installed those things once we found the pieces. But this was the actual piece of the burn through, the piece they were looking for. And we installed the cables, and a big ROV would come along and pull that up. We sent 2 ships, 2 subs, and we were there for 3 months, continuously identifying targets. Still a lot of Challenger is on the bottom out in deep water. But only the pieces that were required for the investigation were brought up. Now, in 1997, we did a mission for the Discovery Channel. We did a special, and that special was done around Cuba. Okay, here we go. And it was called The Forbidden Depths. We worked the entire south coast of Cuba, and we were the first U.S. flag research vessel to visit there in 40 years. At the end of the mission, we pulled into Havana, and we were visited by the president at the time, Fidel Castro. He talked to a lot of people on the ship. There was a lot of security guys around him. I'm pretty sure this guy in the white shirt had a machine gun under his shirt, and there were quite a few of them on board. I showed him the submersible. He was interested in the safety of the vessel and the operation. But then he went up to the bridge and talked extensively with Shirley here about things. And behind Shirley there, the other gentleman is our good friend, Al Giddings, who is the filmmaker on this particular mission. and the one responsible for setting up this whole affair. During this conversation, Shirley mentioned to President Castro that she would like to dive the north side, and he sort of indicated through the interpreter to her that that might happen because I have influence in these things, you know. So, and I think that was it on that. All right. Gulf of Mexico. Again, we worked extensively over the years. Now, the Sea Links have a 40-year history, so there's a lot of things I'm skipping over. So these are like sort of highlights for us. Gulf of Mexico is an area where there's oil and gas bubbling out of the seafloor. Around those oil and gas seeps are biological communities that use chemosynthesis for their energy source. They have bacteria in their guts that convert that hydrocarbon to energy or a food source. So here's gas bubbling out of the bottom. We deployed a collection tube, and you can see it crystallizing, forming methane hydrates on the seafloor. Our engineers built a thing we call the bomb, which we put those samples in, and it built they're pressure proof, so we could bring that ice to the surface. This is a shot of a big piece of methane ice that's actually lifting out of the seafloor. And the two dots are lasers that were used for size, but our pilot at the time noticed that there was some movement. So they zoomed in the camera and they see these worms crawling around. Turned out to be a new species. They called them ice worms. They got a long, fancy scientific name, I'm sure, but I don't know it. And wound up on the cover of a scientific journal, a brand new animal nobody ever knew about them. Also in the Gulf, we have things called the brine pools, and they are pools of hypersaline, 4 times saltier than seawater, bubbling up out of the seafloor and forming these little pools. This one, in this case, is clear. Can be pretty toxic. Sometimes they have a lot of hydrogen sulfide in them. Various sizes. These are fairly small ones. This one maybe about 10 to 11 inches across. Here we're deploying a collection device for water sample into that brine pool. And you see that interface there. It kind of looks like jello going back and forth with that dense brine in there. And the white stuff you see is actually bacterial mats that were growing around there. They broke loose and they're now flowing down to another pool that's at a lower level. This shot is of a big brine pool, or sometimes we call it a lake, about 100 feet across and surrounded by a ring of mussels, again, living on that chemosynthesis. We actually worked there quite a bit. Here's the Sea Link actually sitting in the brine pool, and that band of mussels goes all the way around it. And now we're sitting in the pool again, and the brine is so heavy, we can't descend through it. So we're just sitting in it, floating, deploying an instrument down to the bottom to get the depth, temperature, salinity, that kind of stuff, with a little winch device that we developed at Harbor Branch. Now in this shot, if you look in the background there, there's that edge of the lake, if you will, or pool with the mussels involved there. Okay. Close encounters. We encountered animals from time to time. I just thought this would be a neat thing to show. And here's a shot of us again, looking from the outside with our external camera looking in. Shirley and I, right? Yeah. And there she is telling me how to drive this up. All right, so the animal we see is a mola mola. This is actually in the Gulf of Mexico also, and an area we've seen them many times there. It's about mola mola, ocean sunfish, about 8 feet across the fins there. So a pretty big animal, very cool. And then we got back to work. Again, Shirley and I in the sub, we're in Bonaire at this point, up against the wall, and a 6-gill shark just came in and started swimming around, and we were just mesmerized by this animal. There's quite a long shot of this thing that we have, but this is just a short clip. Show you the kind of things. It was taken with my GoPro, and there's some glitch, so you see a line going across there. This is in the Bahamas, about 500 feet deep on the wall, and it's a short chain of lobster walking along, nose to tail. I understand they could be hundreds of animals long. I've never seen one that long, but This was done off the coast of Peru, and it's crabs by the thousands. There was a valley there, about 2,000 feet deep valley there, and there were geologists on board. They didn't know what was going on. And got to a point where they were so thick they were falling over the edge, and we kind of nicknamed that the Cravalanche. Now, a lot of people have asked me over the years, what's the strangest animal I've ever seen? This has got to be it. That's the head of the animal, has a little gas pocket in it. Apparently, it can change the volume there so it can extend the head, and the body sort of slinkies along behind it. And we'll see that in just a second here. It's a siphonophore, which I won't even begin to describe. I'm not a scientist. But you can see the body of the animal there, the tentacles, and in the center, what they believe to be an egg case. Now, coming into view here are the long filamentous tentacles that made this animal about 20 feet long. Those tentacles, and they'll just we'll pan on down here. And they were used for feeding and probably for defense as well. They deployed these things, catch little crustaceans or whatever was floating by, and retracted them and then fed on that. So here we go. We're just still panning down and down, like I said, about 20 feet long. And that's that. Another thing I heard over the years is your job must be so exciting, right? And yeah, it really was. But sometimes you just had a bad day and things just blow up in your face, right? Things don't always work as you thought they would. And that's a shot. One of our thrusters filled with water and basically exploded on deck. Nobody hurt, thank goodness. But doing this for a living, couldn't beat it, and I wouldn't have it any other way, wouldn't give it up for anything. So in conclusion, thank you for your attention. And I'll take questions at this time. Okay. All right, questions? Yeah.
You started in the 70s. Was there any regulatory authority, and is there any regulatory authority today on submersibles?
Okay, the question is, in the 70s, was there any regulatory authority like for the safety of the manned submersible, and is there today? Yes, there was. There was American Bureau of Shipping. However, in the 70s, and there was also ASME, this, let's see, American Society of Mechanical Engineers, who had a subcommittee called the Manned Undersea Vehicle Committee, and they developed a bunch of rules and pressure vessels for human occupancy. ABS, though, at the time was very new on classifying manned submersibles. So a lot of our engineers actually helped and served on some of those committees to develop the rules that are now in place. But if somebody wants to take a submersible and take it on their own, build it themselves, take it on their own, they don't have to follow those regulations. If you take a paying customer, you might have to in the US. Yeah, another question.
Yeah, did Shelley go with Castro at the Garden of the Queen?
Yeah, the question was, did we dive with Castro in the Garden of the Queens in Cuba? Shirley, you can answer that better. No. Well, first of all, Castro did not get in a submersible. It was offered to him, I believe, in the early days, but the government decided no, that was not going to happen. We did dive in the area, the Queens, both, the Garden of the Queens, and inshore and shallows, and the submersible over the edge. Yeah, so it was very interesting. The waters and the reefs off of Cuba are amazing, just absolutely amazing. Another question? Anything? No? Oh yeah, I'm sorry.
Let me ask you, when you did the Gulf Stream,
Yeah,
and when you did the sipping pool,
yeah.
okay, you are picking at, I can't know, methane.
Methane, yes,
Methane?
yeah.
Okay, that is supposed to be a very volatile type of
Yeah.
liquid material, whatever.
Material, yeah.
Means what was the reason you brought it up?
Ah, okay.
And in Yeah, what was? the reason
Okay.
for the-
The question was, when we were working in the Gulf of Mexico, what was the reason we brought these samples up of the methane ice? It was just that it was the scientists looking at it to determine what the composition of that gas was. Okay, because it was not only methane, there were other components in there, other gases, volatile gases, like hydrogen sulfide was in there, small portions of benzene, I believe. So they were looking at it just to see what the composition was. The problem was the methane ice, as you bring it up, the pressure releases just like dry ice. It would sublime and turn into gas. So that black instrument was developed by our organization to put that section of ice in there. We put the lid down and it came up under pressure. Then the scientists could siphon off the gas later on in the laboratory rather than lose it all on the way up.
For the lockout dives, was there a criteria on who could be a lockout diver, and did you ever lock out?
Oh, the question was there criteria for being a lockout diver, and did I ever personally lock out? Yeah, there was a criteria. You had to be trained in the equipment. You had to have, of course, be medically fit. So we all went through, actually, we went through a series of medical tests, including long bone surveys. We'd have to go periodically for that. But the training happened right there on the facility. Like when I mentioned the archaeologists, they were divers, scuba divers. And we took them and trained them in our system how to, react and act as a lockout diver. Yeah. And we had a set of protocols written up. It was very formalized that you had to adhere to. Thanks for the question. Yeah, got one from home.
I have actually 5
Oh.
from Zoom, and you don't need to repeat the questions because
Okay.
I'm going to stand nice and close to the microphone to make sure you get them.
Good.
Okay, so Bonnie asks, how did you learn to be a sub pilot?
Oh, I actually learned to be a sub pilot at Harbor Branch. I started running the decompression chamber. That was my original job, and as a lockout diver. So yes, I did. I didn't mention that before, but I was a lockout diver. And I was trained as a commercial diver, but got the job with this company. Instead of going to the Gulf of Mexico to work the oil fields, I started working for science.
Okay. Chris asks, what was the fate of the Johnson Sea Link?
The Sea Links were retired in 2011, and both of them still exist at the facility at Harbor Branch. One is in storage, the other one's on display for a regular tour. So they're still there, not operational, but they are still in existence.
Okay. Bonnie again asks, how many dives did you do a month? About
hard to say because the missions, most of the heavy diving was done, of course, during the good weather window in this area. Okay. In a month, I would gather, so we've had several hundred dives a year. I don't know, maybe 50 dives in a month, sort of on average, if you will. But a lot of it was centered on the good weather window.
that makes sense. I'm sure you could guess something like this was going to be a question, but Hunter asks, thoughts on the Ocean Gate Titan disaster?
The Ocean Gate Titan disaster. Unfortunate story, of course. Yeah, the thought on that. Well, I don't want to talk badly of anybody, but certainly a lot of shortcuts were taken in the interest of ego and in the interest of making money. That's my thoughts on it. It looked like it was something that was inevitable. And that's, yeah, an unfortunate series of events.
Chris asks, are there any other manned submersibles doing this kind of research today? In particular, are there any with lockout systems as well?
Good question. I wish I knew the answer to that. There are subs still working for marine science, of course. Alvin in the United States, funded by both NOAA and the Navy. The Russians have subs. The Chinese have subs for science. The Japanese, many of them still out there. I am not aware at this particular time. I can't think of a lockout submersible that's in operation for science. There may be, but I'm not aware of it.
Okay. Another question was, are there any books you would recommend for this topic?
Submersibles. Books on, yeah, well, there's lots of books on the history, but some of them are hard to come by. The Man Submersibles by Frank Busby is one. Very interesting history there. Think what else is there? No, I can't think of one. Sorry.
That's okay.
Sorry to say.
That's 500 in this collection.
Yeah, I know a lot of them. Off the top of my head, I can't. I'm sorry.
Okay.
I have a question.
Yeah.
On the samples that you brought up,
Mhm.
what was their percentage of survivability
Oh,
coming from depth to the surface? And did you have to come up slowly? Was there anything you could do to improve their chances?
the question was on the samples that we brought up, what's the survivability of the sample? Was there anything we could do to mitigate that? I would say probably 70% of the stuff came up and was dead. Okay. There were things you could do to mitigate it. That basket that I showed out on the front on one of the videos was replaced by a plexiglass box we called the bio box because it was sealed when it was closed. It kept the water temperature very cold, like the plexi buckets with the lids on it. And that way the animals would survive because they're still in cold. That was the biggest factor, was they come up through warm water and that would kill them off. But the animals with a swim bladder, if we collected a fish, they didn't survive. We had no way to mitigate that. And they would expire. The sponges would come up even in the warm water, and they still survived when they brought into the lab. Yeah. So it was just a hit and miss, but I'd say probably 70%, didn't survive, didn't live. Another question?
One more was, did you provide hot water to the divers?
No, that was not an option in our system.
Oh, well.
There was, something like that requires a lot of energy to produce, and we're limited by the battery capacity on the submersible. And so, no, unfortunately not.
Okay. Well, I'm seeing lots of people type in the chat. Thank you for an amazing presentation. So I'll pass that
thank you.
along.
Appreciate it. Thank you, guys. Another question?
I was just gonna follow up on Lisa's question. Of the 30% of the animals that were still alive when you brought them up, what was their ultimate fate?
Yeah, the question is, of the 30% that came up alive of the samples, what was their ultimate fate? And I would say the ultimate fate was they wound up being studied for a short period of time, and then wound up in a sample collection, probably in ethanol and little bottles. Does that sound right? There's a scientist. It depends on what the mission. Yeah, that's true. Some of the samples, like the sponges, were brought up and cryopreserved, and they could last for years in cryopreservation. So, okay. All right. Thank you.
All right. So thank you so much, Don, for an amazing presentation. And we do have a little thank you gift for being our July speaker.
And we also want to thank Don, who's been very helpful and instrumental in connecting us to Harbor Branch and several different featured exhibits with the ironclad, with the monitor, and Shirley with the sponges. So these two have been longtime supporters and members, and we appreciate everything that you've done for the museum.
Thank you very much, Lisa.
Normally, we give our speakers a year-long free membership, but since you guys are such dedicated members already, you are both going home with this really nice Sea Hunt shirt. Thank you, everyone, for coming tonight. Thank you for those who joined us on Zoom, and
thank you all.
have a great night.